This video is going to have a look at how do we determine the term number of a value within our geometric sequence. So the general rule for a geometric sequence that we are basing our calculation on is Tn is equal to T1 times by R to the power of n minus 1. So that is the term value is equal to T1 times by the common ratio to the power of the term number minus 1. And it is that term number that we are going to try and find in this example. So let's go ahead and have a look at how do we find that term number. So in this example, it gives us the first four terms of a geometric sequence, and it wants us to determine what is the first term in the sequence that is going to exceed 1 million. And the first four terms are 5, 15, 45, and 135. So to be able to determine what is the term number that first exceeds 1 million, I need to be able to write the rule for this sequence. And to write the rule, I need the first term, which is going to be 5, but I also need the ratio. And to do that, I can divide T2 divided by T1, so 15 divided by 5, which is equal to 3. So I can see that my common ratio is going to be 3. So applying that in my first term of 5, the rule is going to be Tn is equal to 5 times 3 to the power of n minus 1. Right, so now that I've got that rule, what it is really asking me to do is substitute in 1 million into that term value. So when Tn is equal to 1 million, what is our n value going to be? So I can substitute that in. So 1 million is going to equal to 5 times 3 to the power of n minus 1. So I've only got one unknown, and that's sitting up in the power, and it's the value of n. So I can go ahead and simplify that by dividing both sides by 5. So that is going to leave me with 200,000 is equal to the 3 to the power of n minus 1. So that is as far as I can go in terms of rearranging the equation. What I do know is that 3 to the power of n minus 1 is equal to 200,000. So I can do guess and check by substituting in estimated values of n to see which one gives me a value of 200,000. So for example, I could start off by substituting n is equal to 10. N is equal to 10. So that is then going to be 3 to the power of 10 minus 1, or 3 to the power of 9. And that is going to equal to 19,683. So since for that I haven't hit that 200,000 that I'm looking for, I go ahead and I can see that I'm probably a little bit off of that 200,000 because I'm only sitting at 19,683. So I might skip a number and I might go n is equal to 12. So substituting that in, 3 to the power of 12 minus 1, and that's going to equal to 177,147. So I'm getting closer to that 200,000 number that I'm looking for, but I haven't quite hit it yet. I think I'm going to be pretty close. I'm not going to skip a number. I'm going to go n is equal to 13, substituting it in, 13 to the power of 13 minus 1, and that's equal to 531,441. So I can see that I have indeed gone past that 200,000 I'm looking for. And that is what I want. I want to know from when I go from being below that 200,000 to being over that 200,000 number. Because in terms of the sequence, what it means is I'm then going from below 1 million to over 1 million. And so that point is going to happen between the 12th and the 13th term. So to answer the question, I can see that the first term that's going to exceed 1 million is going to be the 13th term. So therefore, 13th term is going to be the first to exceed the value of 1 million. Now, if I wanted to check that, and it's quite often a good idea to be checking our calculations, is I can substitute in that value into my original rule. My Tn is equal to 5 times 3 to the power of n minus 1. And I can check that to see whether that is in fact past 1 million. And I can also substitute in n is equal to 12 to check that that term is below 1 million. So when I substitute n is equal to 12, it becomes T12 is equal to 5 times 3 to the power of 12 minus 1. And that is equal to 885,735. And then when I substitute in n is equal to 13, it becomes 5 times 3 to the power of 13 minus 1. And that is equal to 2,657,285, which confirms what I was originally looking for, that the 13th term is the first term that exceeds 1 million. Before we finish off the video, it's important to note that when you are using this method, pretty much the guess and check method of finding out what that n value is, it's important that you are showing at least 2 substitutions into the formula to make sure that you are showing that the before and after value, which shows when it does actually pass what you're looking for. So here, we've got to make sure that we're showing the before value, so n is equal to 12, and the after value, n is equal to 13, to be verifying our answer. So just remember, you need to be showing at least 2 substitutions before and after to be able to prove that you have mathematically worked it out. So that's an example of how do we find a term location of a value within our geometric sequence.